In this video, we are going to go over conjunction, which is also called an AND statement. Let's take a definition. Let P and Q be any statement, then P and Q denoted by this PVQ is always true if both statements, that is P and Q, that is the P and Q statements, are true. It is always true if P and Q are what are true. That is, if the both statements are what are true, it is what it is true. Otherwise, it is false. So now let's take this example. And see. Also, we said that if you're given this kind of equation to solve for P and Q, this P and Q statement, we are going to use a truth table to illustrate this, and this is a truth table. We are going to say P and what and Q. So under P, since P is the first statement, we are going to have what 2 true and what 2 false. For the second statement, we're going to have what true, false, true, false. So now, in order to look for our P and Q, remember that from our definition we said that what? We said that P and Q is always true if P and Q are what? If P and Q are true. Otherwise, it is what? It is false. So now, we are going back to P and Q and check if the both statements are true. So now, under the first line, we see that we have, under P, we see that P is true and Q is true. So then, our P and Q is going to be what? True. For this, for the second one, which is under P, we see that we're having true here and here is false. So it is the otherwise. That's why we're having what here? False here. If you check again, the both statements are not true. Then it is what? False. The both statements are not true. Then it is what? False. So if we check for P and Q, which is the reverse, the converse of this, we're going to see that it will give us the same value, because P and Q and P are what? Are commutative. That's why we're having the same value here. The both statements are commutative. That's why we have the same. That's why we're having the same value here. So now, let's move to example 2. Where we have P and what? And negation of P. So here now, how many statements do we have here? Obviously, it's one statement, because we're having P and negation of P. So before we proceed, or before we go into this, let me explain negation. Negation of P simply means that if a statement is true, the negation is going to be what? False. If a statement is false, the negation of that statement is going to be what? True. So if it's true, the negation is false. If it's false, the negation is what? True. So now, so we're having just one statement because it's P. So it's one statement. You understand? It's one statement, not two. Take note, it's one statement, not two. We're only taking the negation, P and its negation. So it's one statement. I remember we are going to have, we're having, now to get our truth table, we're having 2 raised to the power of n, where our n is the what? Is the number of statements we have. So here now we're having just what? We're having just one statement. So if we raise that 2 to the power of what? 1, we're still going to have 2. That's why we're having T, which we're having 1 true, false. Yeah? 1 true, 1 false. Then the negation of P now. Negation of P, like I said before, if P is true, its negation is going to be what? False. That's why we're having false. So it's false here. Its negation is true. So now to get P and negation of P. Remember from our definition, we said that AND statement, if both statements are true, then it is true. It is always true. Otherwise, it is false. What it means by otherwise is what? If if we didn't meet up with the requirement that said that if both statements are true, then it is not true. The statement is not going to be true. So now we check now to see if our condition, if we're going to meet up with our condition. So what's the condition? If both statements are true, that is P and its negation, are they true? No. So that's why we're having false here. Are they true? P and its negation, are they true? No. So that's why we're having P here. And since we said that under truth tables, our truth tables, we have 3 results for truth tables, where we have contingency, we have contradiction, and we have tautology. So tautology is when your results are true, all true. It means the result is what? Tautology. Then if the results are all false, then it is called what? Contradiction. Then if you're having both contradiction and tautology, then your result is going to be what? It's going to be contingency. It's going to be contingency. So therefore, this our result here. The result we got here, since it's first all true, our result is going to be contradiction. Thanks for watching.